going to do the last two questions of the challenge questions on SOHCAHTOA last week. So this one, we have a boat is approaching a cliff with a lighthouse on top. Okay, so let's just get what's going on. So let's have some sea. Okay, and then we have cliff. Okay, so we're told that I'll just pop a little bit here. That's as good as my artwork there. So the cliff is 80 meters high, and the lighthouse is 20 meters tall. Okay, the angle of elevation from the boat to the top of the lighthouse is 25 degrees. So let's join up from the boat to the top of the lighthouse. Okay, so the angle of elevation is going from the horizon upwards. Okay, that's 25 degrees. Calculate the angle of elevation from the boat to the top of the cliff. So this time we go from the boat to the top of the cliff. So we want this. Right, I don't know what it is, so I'm going to call it. Right, give your answer to the nearest degree. Well, let's look at the first the triangle we're aiming for. So we're trying to find this angle here. Now to find that angle, we need two sides on our triangle. But we only have one side. So we can either get the hypotenuse, but we have nothing to get that with, or we can get the distance, the horizontal distance from the boat to the bottom of the cliff. That's going to be more helpful, so I'm going to call that distance x. Now in order to find that, we can use the higher triangle from the boat to the top of the lighthouse, because we know that full height, we know that angle of elevation, so we need two things, and we're going to find the third thing. Okay, so I'm going to sketch that triangle. Okay, so this is from the boat to the top of the lighthouse. We've got 25 degrees angle of elevation, and the total height there is 100 meters, and we want how far the boat is from the base of the cliff. Okay, so right angle triangle, we have an angle involved, so we can label opposite, adjacent, and hypotenuse, can't we? So we've got hypotenuse is the longest side opposite the right angle. The adjacent side is touching the 25 degrees on the right angle. The opposite side is opposite the 25 degrees. We have information on the opposite side, information on the adjacent side. So if we write down SOHCAHTOA, write something on the opposite and the adjacent side. So we're going to be using tan. So we've got tan of the angle is equal to the opposite side over the adjacent side. We need to solve that equation. Well, we don't like having the unknown in the denominator, so let's multiply sides by x. And then to get the x on its own, we're going to divide by this whole section, tan 25. So x is 100 divided by tan 25. Calculator to see what. So I've got 214.5 degrees. 5 meters. Okay, right, excellent. So now we can think about doing a green triangle, which takes us from the boat to the top of the cliff only. And so we know that's only 80 meters high. We know the horizontal distance is 205 meters. We don't know the angle, that's what we want to do, the angle of elevation. Okay, so let's label our triangle with hypotenuse, adjacent and opposite. got something on the adjacent side and the opposite, so we're using tan again. Okay, so we write down our equation. So tan of our angle is the opposite over the adjacent. So to get rid of tan, we need to inverse tan. So we do that to both sides, which means we just get theta left on the left-hand side. And we type the rest into the calculator. So that gives 20.5 degrees. And it says to the nearest degree, so actually 0.45, so round correctly. The answer button on my calculator is good. Then the angle of elevation is 20 degrees. Final question. This time, no real life stuff there at all. The diagram shows an isosceles triangle, so we know that the one end up as well, attached to a semicircle. There, which is going to be along the line of symmetry. Okay. The area of the triangle is equal to the area of the semicircle. We have to find the exact value of tan x. Let's just think. So we've got that isosceles triangle. We've split it down the middle. So there's an x there, and we'll have an x on the other side as well. To get tan, we would do the opposite over the adjacent. So I'm going to call the adjacent side h because it's a bit like the height of the triangle. Okay, and the opposite side is the radius of the semicircle. So I know that I don't know any of this at the minute, but I can use this statement. The area of the triangle is equal to the area of the semicircle. So let's go with the semicircle first of all. So to get the area, we're going to do a half pi r squared. Okay, and we know the area of the triangle is going to be a half times the base, which is 2r, times this mystery height we don't know. And we know these two things are equal, so let's set them equal to each other. Half pi r squared is equal to a half times 2rh. Well, we could multiply both sides by a half, and we get pi r squared is 2rh. We could divide both sides by r, so we get pi r is equal to 2h. And we're aiming to get tan x. So let's just think, if we put tan x in terms of what we've got, so opposite is r, and the adjacent is h. So let's use our equation and get r over h. So to get r on its own, we need to divide by pi. Okay, and then to get r over h, we just need to divide both sides by h. So we get 2 pi. So that means that tan